To consider the coordinating effect of a price leadership band in a simple price leadership model, let's consider about the simplest possible setup with just two banks, Bank 1 and Bank 2, where Bank 1 will be the leader and Bank 2 is going to be the follower. And those banks are offering mortgages which are slightly differentiated products. And for that, we can take this simple demand system setup. So what we have here is the demand for a mortgage offered by Bank 1, which is going to be a linear function. It's A minus BP1. That's your regular demand curves that you're familiar with. But then there's going to be an added component here that is D times the difference between the price of the mortgage with Bank 2 and that of Bank 1. And symmetrically, with the same D, there's going to be the demand for the mortgages offered by Bank 2. It's going to be A minus B P2, its own price, plus D times the difference between P1 and P2. So what this captures, this demand system, it's important to recognize, is that if D would be 0, you just have your ordinary demand curves, but for single individual firms. But what we have here is that if D is a positive value, there's going to be a shifting effect of a price difference. So if D is not too large, there's not going to be a huge amount of shifting of demand. But if D is some number and P2 is a bit bigger than P1, what you get is that there's going to be a slightly higher or a higher demand for mortgages of firm 1. But if P2 would be lower than P1, so this will be a negative term, there's going to be subtraction. So demand is going to shift essentially to the bank with the lowest price, but only by the value D. So this captures this idea that the mortgages are slightly differentiated products, but there's still competition between those products. And if D is large, then it means there's going to be a lot of shifting for small price differences. And so that's a measure of how strong the competition essentially is. So we're going to look at different values of D next. Now, what we want to analyze here is the effects of a sequential move game, competitive equilibrium, and then introducing a price leadership band, the coordinating effect that that price leadership band may have. So Bank 1 is the price leader, as said. Bank 2 is the price follower. And to make matters as simple as possible, we're also going to assume that they are symmetric, so they are going to be equally efficient and in their production. So that's the cost of attracting funding for financing these mortgages. And so we're going to normalize those costs to 0, which means that we can write the profit function of each individual bank like this. It's essentially the revenue function. So the profit of Bank 1 is going to be the price of Bank 1 times the volume sold by Bank 1. So this is Q1. And we know that Q1 is a function of prices P1 and P2 like so. And so we just have substituted here this demand system into the profit function for Q1. And the same for Bank 2. So the profit of Bank 2 is going to be P2 times the quantity sold by Bank 2, Q2, which is expressed as a function of prices according to the demand system here. So this is our basic model, like I said, about the simplest possible model that would capture the dynamic in this particular issue. Now, to analyze this sequential move game, we're going to start at the back. We're going to do backward induction, and we're going to start with analyzing what would be the best response of a Bank 2 to any price set by Bank 1 in the first stage. And by the time Bank 2 is around, it's about to set its price, it knows what P1 is going to be, and so it can actually maximize its profits taking P1 as a given. And so what we're going to do is to solve this is we're going to maximize this profit function by taking the derivative with respect to the choice variable P2. So and the first order condition is then that that derivative of pi2 with respect to P2 is going to be equal to 0. Now that derivative is fairly straightforward. We have here a P2 times A minus B P2 squared. So that is A minus 2B P2. And then we're going to have P2 times D times P1. And the derivative that is this here, and then here we're going to have P2 times D minus P2, and so that's a square again, which pans out like so as a derivative. So this is the simple first order condition for profit maximization of Bank 2, given the price of P1, given the price P1 of Bank 1 in the second stage, and from this we can derive the optimal, the best response of Bank 2. So whatever P2 is going to be. P1 is going to be P2, so Bank 2 is going to set its price like so. A plus D times that P1 level over 2, in between brackets, B plus D. So those are all parameters, and P1 is the choice variable of Bank 1 in the first stage. Now bank 1 knows this best response of bank 2. So now we can look at the behavior of bank 1. So this is what we had just derived. We're going to now take the anticipation of bank 1 into account as follows. So we can write the profit of bank 1, which was P times Q1, remember, where Q1 was a function of prices according to the demand system, where the difference between P2 and P1 featured to capture this product differentiation. So what has happened here now is that this optimal response of bank 2 has been substituted in for the P2 level in the profit function of bank 1. So this is entirely a function of parameters and the choice variable of bank 1, which is P1. And so we can take the first order condition for profit maximization of bank 1, the derivative of pi1 with respect to P1, which is a little bit more involved. But again, you have to multiply this out a little bit and then do what I just did before step by step. And you'll end up with a derivative like that. It's not terribly complicated either. And so set it equal to 0 gives us a condition which is entirely in parameters and P1. So we can solve this, and then we actually have P1, so the price of bank 1, the leader, as a function of parameters only. So this is a number. And this is a little bit of, a little bit of creative algebra necessary. So you have to stare at this a little bit. But in the end, it pans down like this. It pans out like this. A, B, and D are featuring in this expression of P1. So this is the equilibrium value in the sequential move game for price 1. And if you have this as a number, then you can plug it in the best response. And so the follower price will then also follow with some algebra. And the follower will price according to its best response, according to the level of P1. Well, that level is this here. So this has been substituted in here for P1, and that works out like so. So here we have two numbers, P1 and P2, a competitive game solved, essentially. Now, to give this a little bit more, to get a little bit of more feeling for these values, consider a numerical example. Suppose we take A is 20 and B is 1. Then we can express, obviously, P1 and P2 as something only in D, because we had it in D, A and B. Now we have values for A and B, so we end up with P1 and P2 as a function of D only. And then we can analyze, and we will do that next in a slide, in a graph, we can analyze what happens for different values of this product differentiation parameter. But take a half, then actually P1 is going to be this number here and P2 this number. Yeah? So P1 is 8.24 and P2 is 8.04. Those numbers in themselves don't mean very much. But what is important and to recognize is that P1 is going to be higher than P2. So what essentially is going on is the leader sets its price first, and then he's going to be slightly undercut by the follower. So the leader has a higher price in equilibrium than the following bank. And but because the leader knows that this will happen in the second stage, the leader actually doesn't set its price very high. It's being competitively restrained by this, by the fact that the follower will actually undercut it, and so the whole price level is relatively modest. It's a competitive equilibrium in that sense. And this is an important observation also for the analysis of the price leadership band, which will be next. Another observation is we can of course express now the profits also as a number. So the profit of bank 1 works out as this, and the profit of bank 2 works out as that. So that's 96 something. What's interesting here is that actually the profit of the leader is somewhat smaller than the profit of the follower. So this poses an interesting question: why the leader would want to be the leader? Because he would actually be better off as a follower if the follower would be the leader. So the roles that these different firms, or in a general model, or banks in this case, take on, there are some issues there. In part, this is due to the fact that we're assuming symmetry in cost, for example. So if you would introduce some different efficiencies that can take care of this, there's a variety of other arguments for who is the leader and who's the follower and so on. This is not terribly important, but this price difference, for now, later extensions of the model possible, this price difference here is, and actually this is quite general. So if we would draw a graph of the prices of bank 1 and bank 2, so that on the vertical axis we have the prices, and we have the product differentiation parameter D here on the horizontal axis for those values A and B that we have used throughout, then what you see is that P1 is always going to be, for all these values of D, P1 is going to be above the P2 level. So there's this notion that the leader is being undercut by the follower a little bit in the second stage is a general characteristic of this equilibrium. And that is important because the price leadership band, what does it do? Well, it actually says that the follower is no longer allowed to undercut the price leader. So that means essentially what it is naturally doing in the competitive equilibrium, it is now banned from doing by the authorities, by the European Commission in this particular example. So what does that mean for the equilibrium? Well, essentially it has the effect that the response of bank 2 to the price of bank 1 is going to be to set that price equal. So it wanted to actually undercut a little bit. The expression we had for it was something in best response with A and B and D in it, but now it's just going to be on the level of P1. It would like to be below it, but it's going to be it's certainly not going to go above it, which it would in theory be possible. So it would be allowed to do so under the ban. It's going to be on the level of P1. So essentially, the best response of bank 2 to the price of P1 is to set that price equal. And bank 1 knows this, that's going to happen in the second stage under the price leadership ban. And so the price leader is going to write its profit function, and the logic is exactly the same. The profit of the price leader is now going to be P1 times Q1, but Q1 is now the simple A minus B P1. Remember that the profit function used to look like this, with the general, still we have this general product differentiation demand set up. But because we know that P1 and P2 are going to be equal, because P2 is going to be set equal by bank 2 in the second stage to P1, this term actually is 0. So this term drops out, and bank 1 ends up with a simple profit function that's only a function of P1 and parameters. Now, and then it's very simple. You can take the first derivative of this. So the profit maximization under the price leadership band of bank 1 is going to be a dpi1 under the price leadership band to dp1. And set it equal to 0, you get this simple first order condition, which is just profit maximization of a monopolist, essentially. And since we know that firm 2 or bank 2 will set the same price, we know that P1 is going to be equal to this A over 2B, which is going to be equal to P2. And in fact, if you take the numerical example, the prices are going to be 10, where there used to be something in the 8 area, and the profits are going to be 100, where they used to be in the 96 area. So the prices are going up and the profits are going to be at monopoly level, actually. And so what you see in conclusion in this basic model of price leadership by a leader-follower setup, if you introduce a price leadership band of the type discussed, there's going to be coordination from the competitive price leadership equilibrium to the collusive price leadership or monopoly price leadership equilibrium.